motherfuckers. I'm gonna play with this TP4056. Unlike these little boards here that come already made, they're cheap as dirt. You can get them 12 for 10 pennies. We're just wanting to play with just the 4056. Not the protection. We're not adding protection or anything yet. We'll worry about that a little later. Ideally, what we want to do is, you can buy just the TP4056 chips and integrate them into your project. So right here, got the TP4056, the drawing, and so I got my Fluke 233. On one side, I got just a banana input. I'm going to push that directly in the power supply. On my power supply, I'm just going to have 5 volts, close enough to on the money. I mean, it doesn't need to be perfect at all for this because it's got a wider range for that chip. But okay, so the other end of my meter, this is for going to be so we can measure the current draw. So I got this going into the positive rail. Power supply's got the negative rail, and I've got a little LiPo battery here. For the sake of simplicity, I'm not even going to clutter this up with a couple resistors yet. If you look at this drawing here, this is a cute little drawing. Yeah, it's just a chip. A couple little notes on there. So that's what we're looking at. This is sitting up. The chip might be sideways, but really we're going to go over this and then move in closer. So you can see this and pause it and look at it. The programming for the your resistor current set, these resistor values roughly what you're going to get if you want 1 amp at the max, or you want to go lower for whatever reason. And then you've got a temp pin. You're going to just drag that to ground if you want to disable it. We just talked about the current set. Chip ground. VCC, we said we have 5 volts. We'll connect it in here. It might be black, but that's because it's the other end on the meter. And then chip enable. This is a pull up for enable. Really, we're just going to tie it to VCC. We always want it to be enabled for this. It's easy to add a switch onto this and whatnot. And then for the charge and the standby pin, we're going to do a red LED and a blue LED, just like the TP4056 modules have. We'll do the charge as blue, just like it is, and then the red for standby. That's it. The battery positive, negative ties into the ground plane, and battery positive hooks into pin 5. Alright, we won't make this more complicated than it needs to be. Of course, the meter's not on right now. If you think I'm up to phony shit, get the fuck off. I'm not phony. I try, and if it doesn't work, it doesn't work, but I'm not going to be that free energy guy. Alright, so VCC, pin 4. Now the charge and the standby and charge pin are high impedance. So even though you're going to have the LED tied directly, you want to use a resistor in your project, but I'm just because I know I'm only 5 volts here and it's only for a second, then I'm actually going to run these directly just to keep it simple and easy. There's the charging, and then the red here would be the standby. Come on, fat fingers. There you go. Ah, cocksucker. Okay, so those are those two. So because they're high impedance though, it's not going to do anything until it probably switches a MOSFET and lets it pull to ground. So next we need to hook the ground up. Enable pin. We said we're going to tie it directly to VCC. Again, have your buttons or switches as you please. It's your project. I'm just a guy fucking around on the camera. Then your battery positive, and then the negative we are just going to hook to our ground plane like that. That'll work, huh? And then the last one we would need is the temperature pin. We want, actually this isn't the last thing, second to last thing, temperature pin. we're just going to tie it to ground, which is pin 1. That should work like that. And then the last one would be the current set. So let's say for this, let's do roughly 2K. Let's do 2. I got 2.1K here. So this is a 2.1K. This goes between pin 2 and ground. So 2 to 3 if you stand the resistor up like I got it here. That right there should be about all it takes. And right now this is our current. Now, why? I have a feeling that my lead isn't stuffed into the power supply good enough. Oh, I know what it is. I don't have the breadboard sides jumped together as they should be. Now, I think right when we do this set, these lights might turn on because I don't think this battery's charged all the way. Ground. Yep. So something's funky here. Now we should probably be charging what the battery's getting. Let's do that. Let's switch over. I will hook a new VCC. I want to see what this thing's put in the battery. Okay. Disconnect, son of a bitch. Okay. So now we just got the 5-volt hooked back up. On the other end now, pull this meter this away. So best thing I guess would be to stuff a little bit of a wire in one of those. So disconnect this, connect this here, and we've got 2 lines. We've got the VN side, AV negative, V out. Okay, so now let's check this again. Something last time was funny. Okay, so it's just a crappy connection over here somewhere. So right now it's charging. We did it 2K, which is supposed to be 580 milliamps. I don't know if it's just going to hang out right here in the 300 range. It's going a little high. Maybe the thing's pretty charged. We could check that in just a second too, but at least it works. I don't know if you guys want to sit here. That's all the 4056 takes to integrate it into your project. Hope you're able to use this and incorporate it in one of your projects. Hopefully it's as easy as I think it is. Alright, aloha motherfuckers.